All right, so let's focus on graphing this function. I'm going to put our usual x values here. This just helps me to figure out where things are. It's up to you on how you label your axes. So I like to do the usual, pi over 2, pi, 3 pi over 2, and 2 pi. And then the reverse. Then label my y-axis. Okay, and then next step, let's go ahead and put our x values on here. All right, I'm gonna put, let's see, maybe a little star will be helpful. All right, so pi over 4, what does that go? It goes between 0 and negative pi over 2. Maybe I'll put a little star here that says this is x equals negative pi over 4, because I know you all don't write in different colors like I do. Next is 0, so I'm going to put a star here to say this is my next one. All right, then we got pi over 4. Then we got pi over 2. And then we got 3 pi over 4. Okay. All right, I'll do a little xy axes just so we know what's happening. Maybe I'll scooch this over. 3 cosine 2x plus pi over 2. All right, remember the pattern for cosine. It's 1, 0, negative 1, 0, 1. However, we're stretching it by 3, so we need to multiply our y values by 3. So instead of 1, 0, we're going to go 3, 0, negative 3, 0, 3. So that's our pattern. Okay, and then our x values. All right, now all that's left to do is to plot these. So at negative pi over 4, we are at 3. At 0, we are at 0. Maybe green wasn't the best color. At pi over 2, we're, at pi over 4, we're at negative 3. Pi over 2, we're at 0. And then at 3 pi over 4, we are at 3. All right, so it looks something like this. And these will go back down. But I really just care about being able to graph one period. All right, so this is our graph. All right, cosine always looks weird when you just do one period. Okay, so this is the pattern that we always use to graph our functions. All right, now just to make sure that we know our vocabulary and we know how to find all the things, we just want to determine the period, amplitude, and phase shift for each one of these functions. So I'll remind us we have a sine of bx plus c, and we have a cosine of bx plus c. All right, so to find these things, it's helpful to know a, b, and c. All right, so for the first problem, negative 2 sine of 3x minus 7, our a is negative 2, b is 3, c is negative 7. Okay. All right, so first question is, what is the period of our graph? So we remember how we find period. So it's 2, that's a b right there. It's kind of small. 2 pi over 3. That's how long before this graph repeats. Okay. Amplitude, it's the absolute value of a. So that's the distance between the middle of our graph and the top or the bottom of it. And then our phase shift, negative c over b. Negative, okay, c is negative 7, b B is 3. So phase shift is 7 over 3. So we're moving 7 over 3 units to the right. All right, let's look at the next one. Cosine of pi x over 3. So we have to know what's A, B, and C. So all right, nothing's here, so A is 1. B is the thing in front of x, so that would be pi over 3. And then C is what we're adding to it, so C is pi. And we're going to do the same thing, find the period, amplitude, and phase shift. Using our formulas, 2 pi over the absolute value of B. All right, so remember, we can multiply by the reciprocal. So the period is 6, so it's going to go 6 units before it repeats. The amplitude is just the absolute value of our A, so that's just 1. And then the phase shift, C is pi, B is pi over 3. Pi's are going to cancel, so that gives us our -3. Okay, so make sure you know the formulas for all of these and how to find these 3 different things. All right, so the last type of question we're going to do is, let's see, so sometimes you're given a graph and you have to determine the formula, and so the formula is these things where you know A, B, and C. All right, so it says express the equation for the sine wave shown below in the form A sine of bx plus c. In your equation, make sure that A is greater than 0 and B is greater than 0, and C is the least possible positive real number C. So there are actually multiple solutions to this. So here is our graph, and we have to determine how has this been shifted, what's the amplitude, all of these things. So before we get started, we know it's a sine curve, and so I like to go ahead and figure out what's one period, where does it start and where does it end. All right, so this is a sine curve, so remember it's usually, the usual pattern is 0, 1, 0, -1, 0. So we want to find, okay, where does it start from 0 and then go up, then back to 0, then to negative, and then back to 0. Well, it looks like it starts right here and ends right there. Okay, so instead of starting at the origin, it's shifted over. All right, so let's see, from here to here. So this is where it starts, this is where it ends. Okay? All right, well, let's go ahead and get started here. Let's start with the amplitude, because that seems like it's the easiest to find. Okay, so remember the amplitude is the space from the middle of the graph to the top or to the bottom. It's always a positive number. Okay, so our amplitude is going to be 2 here. So remember that's the absolute value of A, so we have to determine, is A positive or negative? Well, we know it's positive because sine goes up first instead of going down first. So we know that our A is 2. So we already have one of our letters. Okay. Next, we have to do a combination of understanding the period and the phase shift to get letters B and C. I'm sorry, you guys couldn't even see what I wrote down here. There we go. Okay, and I'm actually going to pause here because I don't like the videos to be longer than 10 minutes. So let me stop this and I'll come back to it in the next video.